Hey folks, Ben Gilbert here with Engadget, and we've got Palmer Luckey, co-founder and head, I guess, of Oculus VR, makers of the Oculus Rift, that is still in prototype form. We're here at CES 2015, and you guys have the Crescent Bay prototype. We've got one here in a box. Yep. We're going to take it out in a moment. But I figured I'd start off by just talking to you guys about 2015. It's January 5th today or something like that?
January 6th.
6th. So what is Oculus doing in 2015? Can you give me a kind of rundown of what we should expect from Oculus VR in 2015?
Oh, you know that's a tricky question.
Of course I do.
What we're doing so far is we're showing off Crescent Bay, which we showed off at our developer conference a few months ago.
I'm going to start unpacking it while you're talking.
Sure,
Please continue.
So this is the first time we've shown it to the public in any kind of significant way. Like there's been a couple public demos, but so we're just showing off. We have a big giant booth in the gaming section, and we're trying to show people how far we've come. And Crescent Bay really is a pretty good representation of the kind of technology that needs to be in a consumer virtual reality product.
And so Crescent Bay has a couple of important differences from the DK2, right? Beyond the fact that it has sound built in, it also is a lot lighter, a little bit more comfortable than DK2.
It's so thin and light.
So thin. Just like I'm wearing a pair of sunglasses, right? Not quite there.
No,
but
we got a ways to go.
Definitely a lot more comfortable than DK2. Something more on par with something like Gear VR, right? Something that you guys worked on as well.
It's lighter than Gear VR.
Even lighter than Gear VR. There you go. And Gear VR is pretty light, right? It's a pretty comfortable experience.
Yeah, and we've also the ergonomics on this are a lot more refined too. DK1 and DK2 actually have identical facial interfaces because we decided to reuse some of the parts from manufacturing so that we wouldn't have to retool a lot of things. Whereas Crescent Bay is actually all new ergonomics that are a lot more comfortable.
Okay, and the number one thing I wanted to talk about here is, for me, this is my first time using Crescent Bay, just this morning actually, and the screen resolution is similar to that of the DK2. I'll lean back, thank you. But at the same time, it's got. Geez, I'm losing the thread here. It's not as nice looking as Gear VR is what I'm trying to say. The screen is nicer, the resolution is better in Gear VR, but this is able to do a lot more. It's got positional tracking, it's got the spatial audio built in. It's
also running at a much higher frame rate.
And it's running at a much higher frame rate. So when I was using this morning, it was a better experience than what I have with Gear VR.
You got to try the new demos at the booth?
I did. Okay, I've tried all the new demos.
Did you got to try the spatialized audio robot arm one?
I did. That's a good one. And the spatialized audio works, right? Spatialized audio, for anybody at home who doesn't know, by the way, is something happens behind you, you hear it behind you. Something happens to your left, you can hear it to your left, right? It feels like if you were talking, I know you're talking over there, right?
Well, and spatial audio has been around for a long time as a concept, but it's a lot harder to do meaningful spatialized audio when you're targeting someone who's sitting in front of a screen and just moving the virtual camera view around, but their head's actually static in space. In this case, we're actually able to measure how your head moves through space and adjust the sound in real time. There's not much else out there that's able to do that. So I'd hazard to say that the Rift Crescent Bay the prototype has some of the best audio of probably any device you can buy, period.
And the other big addition is much better positional tracking, right? So the DK2 has some positional tracking. There's a camera that's facing you, and it's picking up the IR sensors.
They're infrared LEDs.
Right. So it is picking up those that are on the DK2. But when you're using Crescent Bay with it, it's a different camera that's watching you for positional tracking, and it also enables you to do a lot more in terms of ducking, in terms of being a lot more fine movement, right?
Well, there's two parts of that. One is that the camera is a newer camera that has a much wider tracking volume, so you can, you're not limited to this tiny little cone.
And it's internal to Oculus, right?
What?
It's an internal camera Oculus. You guys made the camera.
Exactly.
Right.
We also have this plate on the back of the strap that has tracking LEDs, and we can do a seamless handoff between the front and the back. So that allows you to actually turn around, lean down.
Right.
Do things that you wouldn't have been able to do with just LEDs on the front.
Okay, so that's an amazing and important addition. The problem is, of course, that there is still a wire sticking out. So I had the benefit of having a gentleman holding a wire while I moved around and did whatever in free space. How do you solve problems like that, where that feels like a necessary improvement for VR, but at the same time, if you have a wire sticking out of your back of your head, turning all the way around is maybe a dangerous idea, right?
I mean, it's definitely a necessary improvement, but the same thing can be said about corded phones and wireless phones. Obviously, they got a lot more useful after they were wireless, but they were still useful when they were corded.
Sure.
I mean,
a little different.
There's kind of two paths to wireless. One is to have wireless video transmission where you're rendering offline and then you're piping it over to this headset wirelessly. The other way is to render on board like you do with Gear VR.
Right.
To be honest, I think in the very long term, the rendering on board is going to be the path that it takes. It's a much more efficient, elegant solution. And the technology to stream wireless video with low latency at high frame rate and high resolution, it's not really good enough to do what we need to do. We're just now getting to the point where you have decent real-time 1080p video transmission, and they're not trying to go above 1080p or go up to 90 frames a second at all.
But in the short term, right, this is a device that is not necessarily exactly representative of what the consumer version will be, but a lot closer than what you guys have shown previously. And in the short term, how do you handle stuff like a wire sticking out if you're turning your body all the way around, right?
As you've heard us say many times, the Rift is a seated experience. We may be showing people
showing non-seated experiences. That's what I'm asking.
But just look in the manual and look at what it says. And it says to only use it when you're sitting down. That's the best way to handle it.
Okay.
Also, it's worth thinking, we do have attendants that are helping people with their experience.
Sure.
That doesn't mean it's the only way to use it. It's just, we have to have people that are monitoring them anyway, so if they can help out at all by holding a cable, they're going to do it. But we can't just put people in rooms and let them figure it out. Actually, that'd be kind of a cool booth design, where you just put them in the room and you lock it, and they have 10 minutes. And they can
just hope for the best. The number one thing I love about the Gear VR Innovator Edition is that gorgeous screen, right? The screen is really amazing for doing stuff that isn't game experiences, especially stuff like virtual tourism or movies, stuff like that. But it's still not as good as it needs to be, and that's a really great screen, right? That's an Ultra HD screen. It's better than 1080p, right? So for me, using that was really enlightening because it made me feel like, oh God, VR needs like 4K or 8K really to really deliver that sense of presence in a realistic sense. Not necessarily in a game world, but in a movie world, right?
Well, like if you're trying to make something that's photoreal.
Right,
like
exactly.
To simulate the real world, we obviously have a long way to go. Whereas I think what are these TVs? These are probably 1080p. I can't say any pixels on them because they're just a little screen.
Sure.
For VR, it's so much more demanding. And in Gear VR, it's become more apparent because you don't notice the resolution limitations as much when you're using rendered content. But when you start taking movies and films and things that you're used to seeing with extremely high fidelity, you could definitely see the limitations of current VR displays. Yeah, I don't think anyone disagrees with you. We're going to need to get up to 8K per eye or so before we start seeing diminishing returns. I can tell you that even at 4K, we're not gonna be there.
And so that to me seems like 10 years away, right? Like 8K phones. I know that phones move at a breakneck speed, but at the same time, like Ultra HD phones still are pretty new and still pretty expensive.
You're right, and phones don't necessarily have that drive to advance much further. They're already at the limits. And that's why we're kind of at this weird intersection where the current virtual reality, I guess, the explosion of virtual reality that's happened at a time when mobile phones brought high resolutions into the mainstream in these little displays. But it also isn't going to go much further without something to push it. If, for example, you can imagine Gear VR, there could be a phone that was optimized not for being a phone, but for being used for Gear VR. And they're like, there's no point in having an 8K phone. There just really isn't. But It could be that those kinds of displays do get pushed for VR. I guess the key is, you're right. There's nothing in phones pushing displays to 8K or 16K. Virtual reality as an industry is going to need to push displays on its own and not just piggyback off the scraps of the mobile phone industry if it needs to get where it needs to go.
Okay, so that aside, my next big grief was field of view. Field of view on human beings is about 180 degrees or so.
It's 270 degrees with eye rotation. Okay,
well there you go. So if you're straight ahead, direct in front of you, 180 degrees, right? If you're
roughly
this way, right?
That's about right.
So the highest we have with any VR headset is about 100 degrees field of view, right?
It's a tricky question.
It's negligible, maybe up to 120, something like that?
There are headsets out there, but mostly professional headsets that go out till 120, 30, 40, 150. The trick is how you define field of view. I mean, the Rift is almost 100% overlap. That is, you have almost the entire view in each eye. The further out your field of view goes, like for example, if I hold my hand out here, I can't see it at all with my left eye. I can only see it with my right eye.
Right.
If I'm going to start going beyond 100 degrees, you need to start having partial overlap between the displays. And a common trick, especially with professional head-mounted displays, has been to reduce the overlap between displays so that you have like 50% on, only 50% of it is stereo and the rest is just out to the sides. I guess what I'm saying is it's pretty easy to make a headset that pushes that field of view number out. It's hard to actually make one that does it and still maintains good stereo overlap. It's a really tough challenge. We're kind of at the limits of what modern optical technology can do. I'd say, a little over 100 degrees is very achievable, but getting out to, let's say, 180 it's a very, very difficult challenge.
I think that concept of peripheral vision is really what I'm trying to get at, right? Like that's the hardest thing is, especially using those kind of experiential virtual tourism things, when you want to like look to your left like this. I mean, I don't know if this is coming across on camera, but I'm kind of like looking to my left or looking to my right. And even right now, while I'm talking to you, I can see some of the audience in my peripheral vision, although they're not perfectly clear.
Well, it's even more than that too.
With immersion, right? Like
and
that's really important.
Like when you're driving, you're able to sense peripheral, actually, like your sense of motion from things coming towards you is actually pretty bad because it's moving fairly slow as it comes directly towards you. It's when it goes by you that it's actually pretty measurable. I mean, I don't think anyone in the VR enthusiast community disagrees with you. We all want higher res.
Right, of course.
We all want higher field of view. They're both really tough challenges, and we're not going to fix it right away.
Sure.
I wish I could tell you, oh man, yeah, we got that in the bag.
I guess what I mean is not, when are you going to fix this? More, how does this stuff get fixed, right? To me, is it like a massive curved screen that goes to here, right? Like, I don't know what it would be. Well, you're the one who does this stuff.
I mean, I could talk a little bit about that.
Sure.
One common idea is that people have gotten from sci-fi is that there can be some kind of VR device where it projects into your retina, and from a single point, it creates a wide field of view.
Sure.
That isn't really practical. You can't project a field of view that's wider than the final optical element. So if you want to have image over here, you're going to need an optical element that is over here, and it's going to need to wrap around to do that properly. And you can't just make the lenses bigger and bigger. I mean, you can make them bigger and get a wide field of view, but imagine how big lenses would need to be to have a 180-degree field of view if they were flat lenses. Like,
it would have to be a pretty big lens, right?
It'd have to be an enormously large lens.
Actually, speaking to lenses, I went and saw another VR headset last night that I thought did a really great job of handling distortion around the edges, right? And they solved it by using a dual lens setup. And I'd love to hear your take on that, because it worked really well, honestly, and it was something that is very different than what I've experienced with Oculus Rift, right? So, yeah.
There are other ways to do that without necessarily going to multiple lenses.
Like software and stuff, right?
I mean, there are other lens technologies.
Ah, okay.
There's other hardware lens technologies. You can correct for a lot in software. It's really a trade-off of cost and weight and how much distortion you want to be able to manage in software. Also, a field of view. The more elements you have in a lens system, the harder it is to get a wide field of view. Like if you're talking about the lens system that I think you're talking about, it's significantly narrower field of view than Crescent Bay or DK1 or DK2. And that's kind of necessary. The more lenses you stack, the smaller field of view is going to get, because if you want to have a very wide field of view with multiple lenses, each of those lenses in the entire stack needs to be quite a bit larger.
Okay, all right. So speaking of Crescent Bay and the future of PC-based virtual reality, you guys have said a lot closer to what you guys want for a final consumer version. I know that you're probably, I don't know that you're speaking at all about what the consumer version will be, but in terms of expectations, right? There's certain things that I know after using Gear VR, for me, I expect path-through on every VR headset that I'm going to use going forward. Is that something that you guys think is really necessary? Something like spatial audio, obviously, you feel like is necessary. I mean, this is getting closer to representing the final version, right? So are there other bells and whistles that need to be there, I guess, still?
A lot of those bells and whistles, the things that you can call bells and whistles are necessities. We know they're good, but you don't necessarily need everything. I mean, like, pass-through is a good feature to have. I wouldn't say it's critical to a good VR headset. A good VR headset needs to do a good job of being a VR headset. By the way, this isn't me saying we won't have it. I'm just saying I don't consider that a critical feature. I mean, like, if you had a perfect Matrix quality VR headset that didn't have pass-through, I'd still say it's a good VR headset.
Yes, fair enough.
it may have shortcomings as a consumer electronics device for the mainstream, but if you have wide field of view, high enough resolution, low latency, if you can lock those critical things that make it a good VR headset, I think that's what's really important. But there's other clear things, like I think more important than something like pass-through would be having input solutions that are also optimized for virtual reality. Because what we have right now is a device that allows you to look inside of a virtual world in a way similar to how you interact with the real world. We don't have any kind of tool that allows you to interact with the virtual world in a way you interact with the real world. Things like Kinect are interesting, where you're reaching out and waving your arms, but I do a lot of things in the real world besides just moving my hands around.
Sure.
I pick up things, and and to do those things, you need a lot more than just moving through free air.
Yes.
I'm not saying that we have the solution to the problem, but I'd say that's definitely something that's going to be critical for the future of virtual reality, is to not just have the visual side, but to have the visuals and the audio side and the input side. And eventually, of course, you want to be stimulating like movement through a 3D space. You want to be stimulating your vestibular system as well.
So that's specifically interesting to me in terms of an input method, because you guys just bought this company, Nimble VR, and I went and checked out their camera, I don't know, 3 months ago, 4 months ago. It's pretty good. It's not perfect, but it's pretty good, right? And it allows you to put your hands into the world a little bit, and it enables some form of pass-through to an extent, and it easily connects. And presumably you guys saw some of the promise there as well when you were buying them.
I can't talk specifically about any ongoing acquisitions, but I can say
Is it an ongoing acquisition? I don't know. That's just a nuts and bolts question. I don't know.
Everything is a process.
Okay, fair enough.
If it's announced, it's good.
Fair enough. Okay.
But the right way to do pass-through really isn't to take, like for years, one of the fundamental problems with 3D technology and 3D video has been that it's relying on a trick in our brain. What we're doing is we're taking one image with the right camera, one image with the left camera, and then just passing those images through to our eyes without any kind of intelligence in between. And then our brain does all the hard work of building that into a 3D image.
Right.
The problem is those cameras are unlikely to be at the right, unless they record at the right interpupillary distance, the right distance between eyes, the scale's going to be off for anybody who watches that 3D recording who isn't exactly the right IPD. And then if you put cameras on the front of a headset, think about this. We're used to rotating our heads, and our cameras, our eyes, are actually recessed inside our skulls. If you put those cameras out here, when you're turning, they're not actually rotating, they're actually moving through space.
Right.
Which can make a lot of people feel ill really quickly.
Sure.
I think that virtual reality is really, it shows how 3D falls apart at the seams. The only way to really do it correctly would be to have some kind of intelligence and understanding of the world where you're able to record the world, as a 3D object with depth, and then reproject virtual cameras into that and then pipe that back to the eyes. That's really the only way you can make this work for anybody. And then you have accurate eye rotation, you have accurate IPD, and it's all, you can calibrate it all in real time per user. It's going to be a long time till we get there. I'm not saying that we're going to do that right away, but that's something that you may have seen in their demo for pass-through. It was not just two cameras piping into each eye. Right. It was a depth camera and another camera laying the real world onto a depth map of that world.
That.
And you can calibrate the IPD, the rotation of your eyes. Then the virtual eyes is exactly where your own eyes are. That's a much better way to do things.
It wasn't a perfect representation of the world, but it was enough so I could take a drink of water, so I could do human things.
And that's the thing. Traditional 3D recording, the reason it's so polished and looks so good at first glance is because it's such a simple trick. It's just normal video recording with one image to each eye. When you're trying to actually understand the world and build a depth map of it, you're going to have a much harder time doing it correctly. So what you saw was probably broken and janky looking. Let's be honest, it was broken and janky looking, right?
Yeah, it wasn't.
And it
great.
was enough to do some stuff. But at least the technology is fundamentally going in the right direction. And in the long run, it's not going to be janky and broken. It's going to actually be by far the best way to capture the world and reproject it into a virtual space. It also means that you're not just, I'm taking the real world and 2 feet to my eyes. You can actually understand that this is a separate object in the real world, and you can actually do all kinds of cool things with it.
Okay, so we've got 1 minute left here.
Uh-oh.
I've got the last question is the same question I finish literally every interview with you.
Let's just end it now. Let's just end it now.
What's your favorite food? No, when is the Oculus Rift coming out? When can people buy this?
We don't have anything to announce at this time.
Woo! Woo!
Engadget! But I'd say that we're working as fast as we can. We want to release this thing. I know it seems some people, they say, oh, it's vaporware. But remember, we were talking about this earlier. We have not even been around for 3 years. We have been around for like 2.5 years, and we released 2 products. First year, we released DK1. Then we released DK2. This is going to be our 3rd year in business.
What about Gear VR?
Well, I mean, then that makes my point even better. 3 products in 3 years. But I mean, really, that's Samsung's product that we worked on them with. So it's not fair for me to take credit for launching that. But we've been around for 2 years, and we launched 2 products. We're going to be around for 3 years. So we'll see what happens.
All right. Well, we're all looking forward to it. Thank you very much for joining us today, Palmer. We'll be up. We're coming up next with an Editor's Choice piece. It'll be me again, actually. So stick around, and you can hear me talk about nonsense. Thanks very much.
Thank you for having me. Thanks for watching.
Thank you, sir.